All right, we're back again, proving triangles similar this time. So we're only looking at triangles, and we have got three different postulates slash theorems, kind of like whenever we proved triangles congruent, we had like side angle side, and we had angle side angle, and all that kind of stuff. We have three different ones for proving triangles similar. So the first one is going to be angle-angle similarity, as you can see here. That will be your AA similarity. And so that means if you can prove that two angles are congruent, then your two triangles will be similar by AA. The next one is side angle side. So this one's a little different than what we've looked at before. You have to be able to prove that two sides are proportional. That means they're not congruent, they're proportional. So you have to set up a proportion for them. And you have to prove that the angle in between the two sides is congruent. So two sides proportional, angle included is congruent. If you can do that, then your similarity statement here would be that the two triangles are congruent by side angle side similarity. All right, and last one would be side 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 similarity. So this one you need to prove that all three sides are proportional. So if you can prove all three sides are proportional, then you can state your similarity statement of the two triangles are similar by side 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 similarity. All right, let's move on to examples. Lots of instructions here. So determine if the triangles are similar. So that's the first thing that we need to do. Are the triangles similar? If they are, write a similarity statement. So similarity statement means triangle XYZ is similar to triangle. And name the postulate or theorem. So we also have to name the postulate or theorem that we use to prove that they are similar. If they are not similar, we just simply write not similar. Show all your work. All right, so number one here, it looks like we've got two sides labeled for us. And then we've also, so that would be like a side, 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 or a side angle side postulate. That's the one we're looking for. So I'm going to look at this kind of like how we did before. We got to bring in all the way back from unit 1 vertical angles. So our vertical angles across from each other, I can code those congruent. So I am going to try and prove side angle side because the angles in between the two sides are already congruent. What that means I'm going to have to do next is prove that the sides are proportional given to us. So I'm going to start with the smallest side on that triangle ABC, so that would be 2. And you have to compare that to the smallest side on triangle EDC, which would be 8. And then you go to the next side on the left, so the smaller triangle, 3, and then compare that to 12. So we're going to write ratios there, and we're going to make sure that they are proportional. So 2 over 8, that would give us a 1/4. And 3 over 12 would also give us a 1/4. So I can check that off, and I have already coded vertical angles are congruent. So based upon the fact that I've proven side angle side, I can say that they are similar and write my similarity statement. So triangle ABC is similar to triangle EDC. And then we have to write which theorem or postulate. So by side angle side, side angle side similarity. Done. All right, number 2 here. We are looking probably at the angles one, angle similarity, because if you pay attention to the two triangles in number 2, there are no sides given to you. So therefore you cannot use anything about proportional sides because there's no sides on the triangles. So we're going to try and prove that the two triangles are similar by angle-angle similarity. So we've got a 30, 60, 90 triangle here, and we've got a 90-degree over here and a 30, so that means this is also a 60. So therefore they have to be similar because we have got at least two angles congruent to each other. So we know they're similar. We can write our similarity statement. So triangle ABC is similar to triangle DEF. Remember, you must go in order. So A was my 30 degrees, D was my 30 degrees, then I went to 90, then 60. And then we have to write which postulate. So by angle, angle, similarity. Easy enough. Number 3, this one looks a little different. So number 3, we know that the isosceles triangle, but once again, we don't have any sides given to us, like with numbers on them, so we cannot prove proportionality between the two triangles. So I'm going to try and prove angle-angle again, because that's the only thing given to us. Knowing that it's an isosceles triangle here, and my vertex angle up here is a 35, what I can do is take 180 and subtract 35 degrees. So whenever I do that, I get 145. Now, knowing that this is an isosceles, you guys should know these two angles are also congruent down here. So I would take 145 and divide it by 2. That's going to give us 77 point, whoops, that is not going to give us 72.5, sorry. I read that wrong in the calculator. So that means these angles are 72.5 degrees. If we come over here to the big triangle and look, that angle is a 70-degree angle. So since that angle and this angle are not congruent, that means we do not have similar triangles here. So you need to say the angles are not congruent, so not similar. All right. Last one, number 4. We do not have any angles given to us this time. So we are not going to try and use angle-angle similarity, and we can't use side-angle-side similarity because they're not connected in any way. But what you should see is that you have all 3 sides on both triangles. So we are going to try and prove side-side-side similarity. Now, in order to do that, we have to prove all 3 sides are proportional to each other. So we need to set up a proportion. Now, you need to go from the smallest side to the medium side to the big side. So what that means is I'm going to look at ABC. 5 is my smallest side. And I'm going to look at DEF. 10 is my smallest measurement. So therefore, I'm going to start by doing 5 over 10. They have to be corresponding in their side length. So then I'm going to go back to ABC. This is like my medium, 7, and 14 is my medium. So I'm going to compare these two, 7 to 14. And then I'm going to look at my biggest side. So my large side and my large side. And I'm going to compare those. So 11 to 22. Now, hopefully you guys can do this in your head, but all 3 of those, 5 over 10, 7 over 14, 11 over 22, those are all 1/2. So your sides are proportional. Since your sides are proportional, we can write a similarity statement. So triangle ABC is similar to triangle DEF by side similarity. Okay. Hopefully that made sense. If you don't fully understand it, pause, rewind, re-listen. Moving on to the next page. Indirect measurement is used to find measures when it is too difficult to measure directly. So we've kind of already done these, so we're just going to revisit them. Joan places a compact mirror on the ground 24 feet from the base of a tree when she stands 36 inches away from the other side of the mirror. So I'm going to draw that really quick first. So she puts like a compact. If you don't know what a compact mirror is, it's a mirror that opens up, kind of lays flat. It's a compact mirror. So that's 24 feet. So I'm going to draw a line. That's 24 feet away from the base of a tree. And then she stands 36 inches. I'm going to make her a little person away from the other side of the mirror. All right, then it says Joan can see the top of the tree reflected in the mirror. So the point is, she is looking down at the mirror, and whenever she looks down at the mirror, she can then see the top of the tree. So what are we creating here? Hopefully you realize we have got right triangles. If her eyes are 60 inches above the ground, so I'm going to label that 60 over here, how tall is the tree in inches? Oh, please circle that. How tall is the tree in inches? So we're going to put an X here, and we want to know how tall in inches. Well, guess what? Oh, it also says draw a picture to illustrate the question. We've kind of already done that. We've got 60 inches over here. We've got 36 inches, but then we've got 24 feet. So we're going to need to convert the feet to inches because we want to know how tall the tree is in inches. So how do we convert the feet to inches? We times by 12. So that will give us 288 inches. So now, whenever we set up our proportion, our X, our height of our tree, will be in inches already. So let's set up the proportion. I'm going to do the heights, so 60 for Joan and X for the tree, over the distance, so 36 over 288. And then, of course, we cross multiply, so we get 36x equals kind of a big number, 17280. And then we divide by 36. So we get x equals 480 inches. It's a word problem, so guess what we need? Therefore sentence. Good. Therefore, the tree is 480 inches tall. Period. All right. Next question, number 2. Let's see. The school engineer wants to check that the height of Simonson's flagpole, oh, I miss Simonson, that the height of Simonson's flagpole is within the limits set by state regulation. So he places a yardstick, so that's important there, so that it is perpendicular to the ground and measures its shadow to be 1 foot. Then he measures the shadow of the flagpole to be 9 feet. So let's, part A, draw the picture to illustrate the situation. So he places a yardstick. Well, we're going to draw this little yardstick here. You guys, a yardstick, you got to think in feet here because everything else is in feet. 3 feet. And then its shadow is 1 foot. So what did we create? Oh, look at that, a right triangle. Then we've got a flagpole. Simonson's flagpole to be specific. Simonson's flagpole, we do not know the height, so we're going to put X. But we know its shadow is 9 feet. And once again, we created a right triangle. Part A only asks you to draw a picture illustrating the situation. So that's it for part A. Go to part B. If the two triangles created are similar, so it's telling you these two are similar, we can set proportions up on the sides, right? And solve that's 2 instructions, write and solve a proportion to find the height of the flagpole. So we want to know the height of the flagpole. So I'm going to do kind of like what I did in the last problem. 3 feet for the yard height, X feet for the flagpole height, 1 foot for the yard's stick's shadow, and 9 feet for the flagpole's shadow. Cross multiply, you get 1x equals 27. It is a word problem, so write your therefore sentence. So therefore, the height of the flagpole is 27 feet. Period. All right, last part here. According to state regulations, the maximum height of a flagpole sign, that's weird, just a flagpole, I don't know where that word came from, is 32 feet. Find the appropriate flagpole shadow length for the state's regulations. So what that means is, if we look at part B, our flagpole was within state regulations, so our flagpole is fine, but we want to find the appropriate flagpole shadow. So let's say we have a flagpole that's actually 32 feet. So knowing that, we do 3 feet for the yardstick and 32 feet for the flagpole and a state regulation. And then the shadow is going to be 1 foot for the yardstick, but we don't know the appropriate flagpole shadow. So that will be x. So when we cross multiply there, we get 3x equals 32. Divide, you get x equals 10.6 repeating. Therefore, sentence, therefore, the appropriate shadow length is 10.6 feet. All right, there you go. If you have any questions, please don't forget to email. If you need a video chat because you don't understand, email, just let us know. And you can go back and rewatch this as many times as you want. I hope it helped get started on your worksheet.